Okay, welcome everybody. I'm just going to start with a quick introduction. So my name's Jonathan. My role at the university is the postgraduate student recruitment manager. So I basically oversee all our outreach activities, targeting incoming postgraduate students. And I'm joined today by Dr. Shakiri Haksa, who's going to talk to us about 5G radio interference with weather forecast sensor satellites. So at this point, I'm not going to say any more. I'll pass over to Shakiri.
So hi everyone. So my name is Shakiri Haksa. I'm a group leader in microwave photonics and sensors here at Royal Holloway, London University, electronic engineering department. So today's talk is about photonic signal processing to remove all 5G, so RFI band signals from the weather signal and radio altimeters. So just a presentation outline. So talk a bit about our microwave photonics group and what actually we have developed so far, what kind of work we do around some challenges, in particular radio interference with 5G, so 5G RFI interfering with weather forecast satellites and also aircraft altimeters, and also explain a bit about some of our work that we already published on using the new technique that we have developed. It's called new. It's not new in a sense. It's more just application in terms of actually applying this technique, which is known for many researchers in the area, called simulated Billion scattering. Our group consists of 3 academics, 3 visiting professors, and around 10 PhD students. Most of our work is around developing sort of techniques that can have control of radio signals over fiber optics. So our techniques are in terms of filtering, identifying the RF signals, filtering them, removing distortion products, and also amplifying the signal. And we can do that for almost any spectrum starting from few megahertz to terahertz. We also apply this technique in terms of cybersecurity, because once you have control of RF in optical domain, let's say moving distortion products and so on, so that's also automatically has an impact on sort of cyber threat sort of mitigations. So the lab that you can see, the pictures that you see here are actually primarily funded by industry. So we have around 15 patents being awarded and over 200 journal papers as a group. So we have all types of equipments that we use in terms of delivering this work, starting from components, systems, tunable lasers, filters, RF sources, and so on. University, a few years ago, has invested almost £500,000 in new RF sources and VNAs, which now we can deliver any work up to 70 gig. So today's talk is primarily on this specific new frequency mitigation. As I said, we developed a new photonic RF spectrometer. So this spectrometer can actually detect any spectrum or any transmission at the same time, multiple transmissions at the same time, and you can also find the angle of arrival. In other words, you can also find the location of the transmission at the same time. And then we also apply this SBS filtering to actually eliminate any undesired, let's say, frequencies. There was an article published a few years ago in Guardian talking about the potential threats of the 5G interfering with the weather forecast satellites. And as you already know, 5G has already, started deployment in many countries. And in order for operators to deploy this infrastructure, they need to also get the permission from the regulatory. I worked myself as a telecom CEO, and I understand how regulators and operators work and how, the rules of regulator must be sort of followed fully by the operators. In this case, for 5G, there's still, lots of sort of unknown in terms of the spectrum and interference and so on. But among the things that, has raised the concern is also that the 5G could actually interfere with weather forecast satellites. So in other words, the 5G signal could potentially leak into bands used by weather sensors on satellites that they measure the amount of water in atmosphere and affect the weather forecast and predictions. This is a huge problem. It's a global problem. Because imagine if the weather forecast, institutions cannot predict the weather, then within, let's say, a few hours, that could actually could cause serious accidents in airspace industry and wider. So in other words, the weather forecast experts rely very much on the data on the satellite collecting this data in order to forecast the weather. And the instruments that actually are sort of designed and are used around this technology are actually vary and they measure the data around, let's say, this spectrum, in particular around the 23.8 and 31.4 gigahertz. But that's the spectrum where actually water vapor, such as rain, snow, cloud, and ice and content, can actually affect the signal propagation. And for those of you who are, understand the RF multipath, that's interference between let's say, this clouds and the water vapor could actually it could cause that this weather satellites collect the wrong data instead of collecting the exact data that has been meant to be collected. They potentially could collect the radio frequency interference by the 5G signals, which are very close spectrum or a neighboring spectrum to this sort of weather forecast or water vapor spectrum. So this article was published in Guardian, and we actually contacted the publisher, and we invited them to show in our lab that actually we can remove this type of distortion products around this spectrum. So in other words, if you see here, this is the region where the main problems arise, and we managed to show experimentally that we can remove and we can keep that spectrum clean. Not only that, but furthermore, there's a huge challenge coming along that is moving towards millimeter wave. And as you know, if you work towards millimeter wave, that we're working towards 300 gigahertz. And that, again, there's another challenge around 60 gigahertz, where actually the temperature will also affect the satellite sensors collecting the data. So in other words, this is a global problem that needs to be tackled. It's still at the early stage. We're working with the main stakeholders such as Met Office, European Space Agency, and also companies that actually manufacture the instruments for both of these companies, these institutions. So we have received funding from European Space Agency, where we actually working around that, and we managed to actually develop the technique to keep the spectrum clean and avoid this type of radio interference. So again, this is a global challenge that has been identified, published in Guardian, published in Nature, and also been on the news, on the Sky News. I don't know if you've seen the video shared by Jonathan. Well, actually, they see this as a huge problem in terms of the impact of the global warming as well. So the more data hunger that we go, the more traffic we have, the more spectrum efficiency is required. And our group has unique skills that we not only that we can optimize the spectrum, but we can also survey the spectrum. So we are able to detect almost any interfering frequencies. It could be as weather, in this case, predictions or weather changes, or a man-made. Let's say if you have a potentially man-made sort of, let's say, malicious signal, we are able to detect that signal, we're able to block, and we're also able to find the origin of that, let's say, threat. Another huge potential risk that has been also identified primarily in USA, and this issue has been raised and discussed in the White House, and President Biden was involved directly on this one. And that's to do with 5G, again, deploying BTS antennas around airports in USA. So actually the government, US government has intervened and actually blocked the operators to deploy the 5G BTS antennas around the airports. And the reason is that the 5G could actually interfere with the aircraft altimeter. So as you know, aircraft has an altimeter radar that transmits the pulse on the ground, and then based on that, it lands or it finds the latitude, into the airports, around the airports. But if 5G interferes with that, then it's a serious issue. So operators, they were sort of fighting to, deploy these BTS antennas, but the government couldn't take that risk, and these BTS antennas actually are not allowed to be deployed in USA. So as you know, this is the airport, sort of the aircraft, and this is the tower. I just happened that also I used to work as a weather forecast in the aviation industry, and the information that the weather forecast or experts collect, they provide that to the pilots, and then based on that, they sort of find ways to land the aircraft. And if there's any interference, that could lead to disasters. So as I'm just citing the Guardian newspaper, saying this type of issues are actually so severe that they claim this is between life and death. So in our technology, in our labs, we can actually remove or actually avoid these type of disasters by developing this type of filters that I mentioned to you. And these filters could be placed on the mast here, or they could be on the aircraft. So in other words, we are able to keep the spectrum clean and avoid these type of disasters. So just going back, why this sort of issue between the US Civil Aviation Authority, Ofcom in this case, that's the UK regulator, and EU Aviation Safety Authority were concerned and are still concerned about the 5G spectrum or 5G RFI interfering with the altimeters in this case, or the weather forecast. In Europe, the 5G network infrastructure is getting better and better, more deployment, but that's not it has been identified that's not a big issue, and the reason is that the spectrums 3.4 to 3.8 they're not that close where altimeters actually operate. The altimeters operate around 4.2 to 4.4 gigahertz, and you can see that 4.2 to 4.4. If you took the lower emitter of the radio altimeter and the upper on the European 3.8, 4.2, the regulators, they still believe that's quite big sort of space between them. But just to take, let's say, a hypothetical case, if, let's say, due to weather issues and global warming, then there is still potentially a risk. And I know from talking to experts in this area that that BBC in some cases they did approach some experts to confirm this. It is quite difficult for anyone to claim that there will be no sort of risk at all. So again, this type of techniques to remove this type of potential distortions or interference are very important. So in Europe, as I said, Europe is not an issue, but the more high risk are in USA, and that's why US government with valid reasons took a decision to not allow operators to deploy the BTS antennas around airports, because if you see that the spectrum allocated for this for 5G sort of operation network if you see starts 3.7, and if you compare 3.7 with 3.8 with 4.2, sorry, then again they're quite close. In other words, another issue. The South Korea, this is where South Korea has, this sort of, 5G frequencies, but in general, due to bad weather and military signal, potential military interference, there's always a risk that this could affect let's say, the aircraft altimeters. So we have developed this technique. We have patents being awarded in this area, funded by one of the largest Europe defense industry. And here we have also published some results in this IEEE transaction in December 2023, where we actually take the signal, we apply this SBS filtering, and SBS is, in other words, is simulated Brilliant scattering. For those of you who are not familiar with simulated Brilliant scattering, simulated Brilliant scattering is a negative impact in the fiber optics. In other words, when the light is traveling around along the fiber, there's interaction between photons and phonons, and this type of interaction causes acoustic vibrations, and it's a negative impact. It deteriorates the signal traveling a long distance. However, what this sort of back reflection of the light from this phenomenon, we took advantage of that, and we used that actually to remove distortion, or in other words, kill this sort of interference and keep the spectrum clean. At the same time, we also use the same technique to amplify the signal. So here we have some ways of actually, getting a signal. If you see around 12 gigahertz here, we amplify a signal, we filter and amplify. But often, when you amplify too much, then obviously you amplify the noise floor as well. But if you look at the signal strength, between these two sort of measurement, there's a huge amplification of signal, and that's a filtered signal. We're talking about filtering, and we're talking about identifying, filtering, and amplifying the signal at the same time. And we can do this for multiple signals at the same time. What is very sort of important for this technique is that it can be applied dynamically. You can do multiple signals at the same time, and using this type of techniques where it involves microwave photonic mixers are very important and unique in terms of future high-speed communication as well. And as you know, 5G, 6G, and beyond, they're moving towards terahertz, and for that sort of high speed, it is almost impossible to deliver signal just using microwave engineering. So you have to involve photonics or optics control the RF, and here are our skills where actually we have full control of the RF frequencies through in optical domain. Our main strength is working on the receiver side. So basically we have the skills to control the RF in an optical domain. Another publication that we published again is on looking at filtering and amplifying the signal. Here you can see, let's say, signals, before amplification. These are filtered signal. You can see after we apply the SBS amplified. Again, so some challenges are in delivering these type of techniques are, controlling the light polarization and so on, but still, again, we have techniques to also do that. There is a huge sort of advantage of microwave photonics or photonics compared to electronics in terms of, future 5G, 6G, and future communication, high-speed communication systems. Electronic filters are not that great. They have low Q factor, noise is high and bulky. We're actually deploying microwave photonic mixers or filters that have a huge advantage in terms of low electromagnetic interference, low losses, low drift, very small size, and a huge bandwidth. So in other words, you're talking about comparison between electronic mixers and microwave photonic mixers, which has been also confirmed by the US defense agency DARPA, where they have confirmed that microwave photonic mixers are 30 30 dB better, which means 1,000 times better than electronic mixers in all aspects. So in this case, we make use of this type of technology, apply this SBS filtering, and we achieve this so-called notch filters. And these filters are very narrow. They go even to 0.4 megahertz, and they're dynamic. And as I said, you can apply them, and they can apply along the spectrum, and they can cover the whole spectrum. So our main advantage in this area is that we use existing component of the shelves. So we are not relying on, let's say, fabricating new photonic integrated components or circuits. All these components are available on the market. We purchase them primarily in UK, Canada, and USA. And our main sort of modules are primarily around 3 to 4, TRL, technology, so readiness level, which means we are ready to actually deploy this type of technology in existing, let's say, infrastructure. When I say existing infrastructure, obviously there are some challenges to actually integrate sort of, let's say, this type of new emerging technologies with existing infrastructure, but technology is moving forward. There's so much demand now for high bandwidth. If you look at the driverless cars, and there's so much, AI is applied now, almost communication to device communication. There is an urgent need for actually to keep the spectrum clean, to survey and optimize the spectrum. In other words, we have skills to optimize 5G, 6G, and beyond, and also identify or sort of survey the spectrum and identify the location of transmission as well. So in other words, as a summary of today's talk, so we use this type of technology without loss of an RF performance. We use small size, which swap as it's called, size, weight, and power components of the shelf, which have unique sort of beneficials. And these filters are so basically deployed dynamically, so it can remove these distortion products along the spectrum. And also, in other words, the same kit can identify so in the same module, we can integrate the spectrometers or detectors to identify this type of sort of frequencies and remove them. Obviously, this type of new systems, they require calibrations, but we still, have ways to do that. And in most of our technology, we do apply AI. Artificial intelligence has huge advantages in terms of remote and rapid sort of application of this technology. So we work with the main sort of stakeholders in UK to actually deliver this type of technology. That includes my presentation for today. Happy to answer any of your questions.
So we've got some time for questions. If anybody wants to ask any questions on this, please do pop them in the chat. Shakiri, just as a recap, if students are interested in pursuing these kinds of studies, what courses at the university would you recommend, and is there any sort of general guidance you would give on applying? What kind of background students would come from generally on these programs?
Any student with computer systems engineering skills, electronic, computer science, would fit in this area. So anyone joining our, let's say, university, they have opportunity to, attend modules which are directly related to this technology. Our programs, including, modules at undergraduate, are very much aligned with actual research skills that we have. So in a sense, our teaching is somewhat research-led, let's put it this way.
Okay, great, thank you. It looks like we've got a question coming in. I can see somebody typing in the chat, so I'll just give that a second to come in. I'll also pop my email address into the chat in case anybody wants to follow up with some questions outside of the meeting. Okay, so a question from Dean. Coming from the BSc Computer Science and Information Security background, you mentioned how this has applications in cybersecurity. Is this something that I could focus on while studying?
Yeah, So I'm working with the ISG group in our cybersecurity. This is very much actually DAC related to that. So what we do is more sort of hands-on experiments. So in other words, we identify these frequencies, and we use our measurement kit to try to see where that frequency is, and apply, let's say, these techniques in our system configuration to remove them. So this computer sort of, I mean, students with a background in BS in computer science informations are the right skills to apply for. So we also use different techniques to around counterfeit, so preventing counterfeiting and tampering products. And again, students also having a background in this are very important. You always, I mean, if you join the research group, or if you also join in masters, you as always, are welcome to attend, other modules in undergraduate and postgraduate, where we cover fiber optics, microengineering, and advanced communications. Let's say, IoT, sensors, communication, wireless sensors. We have, Vladimir and Benish here, who are also part of the group, and they teach around this area very much related to communication in general. Bear in mind, this is a new emerging technology, and there's a huge demand, into this industry. So we have companies who actually, even before our students graduate, they ask, for the student detail to actually to employ them.
Yeah, it's really useful to know. Another question in the chat. So again from Dean, also being from computer science, I have a less of an understanding of engineering than maybe any EE students. Does the course begin with an expectation of background knowledge that we'd have to cover beforehand, or is it taught from scratch? For example, general processes, methodologies, e.g. using Prince2?
So I'm also a qualified Prince2, project manager. So once you join, we offer you all the skills required. Let's say, if you have hands-on industry, sort of an experiments, we prepare you. You will not allowed to run experiments on your own without being trained. So we provide the training, so you learn step by step. What's important is that you understand the basics, let's say underground mathematics, because we always do modeling before we do anything. We look at the modeling, and then computer skills, like we do programming as well. So programming of let's say applying, let's say, or simulation techniques. Either we use MATLAB, or sometimes we have let's say industry softwares, commercial softwares to use. But just the approach of engineering and computer scientist background is sufficient for you to start with. So the rest, you'll be able to cover, while you learn, let's say, other modules, because most of the modules, they do cover this type of technique, in a sense, the components, the approach, and technology. So once you join, it's just more putting together this type of skills and applying into this particular scenario.
Oh yeah, and Dean says perfect. Thank you. Thanks for your questions, Dean. That's really useful. If you're interested in learning more about the university, generally we have sessions running throughout the year where you can come and join us in person, or you can come and join us online for another talk where we'll talk more generally about how to apply and scholarships and funding and all those kinds of things for your postgraduate degrees. So if you're interested in coming along to one of those events, I'll pop the link in the chat there. Please do come along, or you can just contact me via email. I'm happy to sort of talk through any questions that you might have. Anything course specific, probably better to go to Shaqiri, but anything sort of more university specific can come my way first of all. So
you can Jonathan can also provide my email, because I'm also director of these 4 MSCs in Egham. So we have an MSc in Advanced Electronic Engineering, we have an MSc in Bioscience, and an MSc in Power Systems, and MSc in Fiber and Wireless and Fiber Optics Communication. So I'm happy to help. And all these MSCs actually have the modules that very much prepared for the market.
Brilliant. We've got another question as well. So Parth asks, what are the requirements for studying in this area after completing the CSE MEng?
So I assume Patel, you're asking for either master or PhD. For master, you can join DAC, because during the CSE MEng, actually you have opportunity to actually select some modules which are very much taught at the master levels. If you want to go for a PhD, then you're entitled to go for a PhD straight away in any of these areas, not just in the one that I present today. But for computer systems engineering and MNs, you can also select, let's say you have, fiber optics communication, you have, other modules which are run among these 4 MSCs. Some modules are compulsory, depend on which MSc you're going to select, and some are optional. But you always have an option to select the right module. Our modules consist of 15 credits right now, so you just have to fulfill that criteria, that you can, let's say, achieve the right credit to get the master. But you can, again, if there's a module that you would like, to join and you would like to do MSc, let's say in biomedicine, and there's a module you would like to do, but you go over the limit on credits, we can always find ways to try to see if we can accommodate you there.
So if anybody's thinking about applying for scholarships, hopefully any UK students will already be aware of this, but if not, there's financing available through Student Finance England, which you can apply for. So I'll just pop a link in there after that to those, in case you wanted to do more reading on that.
Always happy for you guys to come and see the department. We can show you the facilities we have.
Yeah, that's a really good idea. The postgraduate events are a really good opportunity for you to come and visit the campus, but you don't have to come to one of those scheduled events. The campus generally is open to the public, so you're welcome to come and walk around anytime you want. But as Shaqiri says, if you contact us by email, we'll try and have somebody come and meet you and show you around. So we would encourage you to sort of get in touch whenever. Okay, another question from Dean. So this might be a bit broad, but what would the nature of the independent project involve? Is it something we choose after finding an interest in the course, or are we assigned one out of a list?
So usually academics provide, let's say, some project brief, but if you're interested in a certain project, then you can come with your project idea. We are flexible in terms of projects. And in most of the cases, actually, we do offer projects working closely with the industry. So sometimes we have projects running now funded direct from industry. We have a group of 4 students working on projects funded by industry. So industry has provided £5,000 to buy the components and the hardware, and the students work on a team. But again, if let's say you start the master, and then within a few months you would love to carry on a specific project related to a specific module, then you could just go and talk to the potential supervisor, and you will actually get the project.
Thanks, Dean. No, thank you for your questions. I think that's probably everything. As I say, if you get any questions that suddenly pop into your mind after the session, feel free to email Shaqiri, myself, and we'll get back to you as soon as we can. So thanks everybody for your time today. Thanks for coming along. Thanks, Shaqiri, for your time and into the presentation. And yeah, hopefully we'll see some of you in the future.
Thank you, guys. Thank you.
Cheers. Thank you, everybody. Bye.